Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. An acetyl carbon, in a sugar context, a glycosidic carbon, is bonded to two OR groups, two oxygens from different sources, no free OR. A hemiacetyl carbon is bonded to one OR and one free OR, the anomeric OR that is not involved in a glycosidic bond. Moving on to the next step. Isomaltose is a disaccharide with an alpha 1,6 glycosidic bond. The C1 of the left, non-reducing, glucose ring is connected via an oxygen to the C6 of the right glucose ring and is also part of the ring oxygen. C1 of the left ring is therefore bonded to two oxygens, ring oxygen and glycosidic oxygen, with no free OR. This makes C1 of the left ring a full acetyl. Count of acetyls is equal to 1. Moving on to the next step. The right, reducing end, glucose ring retains a free anomeric, OR at C1, the reducing end is not involved in the glycosidic bond. C1 of the right ring is bonded to one ring oxygen and one free OR, making it a hemiacetyl. Count of hemiacetyls is equal to 1. And for the final step, the left ring C1 has the O with lone pairs, indicating the glycosidic oxygen, no free OR acetyl, while the right ring C1 has an OR group drawing, hemiacetyl. The question image also shows an HO on the left ring top, but that is the ring oxygen bridge, not a free anomeric OR. A. 0 acetyls, 0 hemiacetyls, incorrect, ignores both centers. B. 1 acetyl, 0 hemiacetyls, incorrect, ignores the reducing end hemiacetyl. C. 0 acetyls, 1 hemiacetyl, incorrect, ignores the glycosidic acetyl. D. 1 acetyl, 1 hemiacetyl, correct. Therefore, the correct answer is D. Therefore, the correct answer is option D.